Welcome, myself Mr. Sarang Mahamuni, Assistant Professor, Satara College of Pharmacy, Satara from the Department Pharmaceutical Chemistry. In this video, I am going to explain and teach Fluorimetry chapter 2nd from the unit 1st under the subject Instrumental Method of Analysis. So without wasting the time, we start with our chapter. So this is of outline of presentation. First is scope, objective of the subject and chapter, and introduction of this chapter, some theoretical part including all principle and phenomena, then instrumentation and application. So the scope. This subject deals with the application of instrumental method in qualitative and quantitative analysis of the drugs. So this subject is designed to impart the fundamental knowledge of the principles and instrumentation of the spectroscopic and chromatographic technique. This is also emphasizes the theoretical and practical knowledge on modern analytical instruments that are used for the drug testing. Then objective of this subject is upon completion of the course, the student shall able to understand the interaction of matter with electromagnetic radiation and its application in drug analysis. So also this chapter is deals with the interaction of matter with a particular radiation. Then understand the chromatographic separation and analysis of the drugs, and perform the quantitative and qualitative analysis of the drug using various analytical instruments. Then the scope of particular subject is will know, then your objective will get know, then we will move towards the topic include in this particular chapter, that is fluorimetry contain for particular theoretical part, concept of singlet, doublet, triplet, electronic state, internal and external conversion, factor affecting on fluorescence and quenching, instrumentation and application. So we complete all this part in this presentation or through this presentation. So first point is the introduction about this method. So some organic or inorganic compound, liquids or solids emit light when they are excited by the photons from the visible or near ultraviolet region. So this is one of the phenomena, that is organic compound or inorganic compound, liquids and solid get emitted the light when they are interact with visible and ultraviolet region. So the analytical application of this phenomena as a photoluminescence, nothing it is but the fluorimetry. So this is the selective and highly sensitive method. The intensity of the fluorescence is proportional to the concentration of the analyte. It is a directly proportional ratio, and the measurements are made with the aid of the fluorometer or spectrofluorometer. So this instrument become fluorometer or spectrofluorometer. Then we will know about what are the photoluminescence or luminescence about this. So we'll come to know what is fluorescence, phosphorescence and luminescence. So that the luminescence nothing but it is the emission of the light by the substances. Already we know about there is a particular energy get emitted in the form of the energy. So it is the emission of a light by the substance. It occurs when an electron returns to electronic ground state from the excited state and loses its excess energy as a photon. So it becomes known as a luminescence, that is from ground state to excited state loses the energy by the emission of the substance in the form of light. So there are the three types of the luminescence: fluorescence, phosphorescence and chemiluminescence. So the phenomena is related with the spectroscopy of this fluorescence becomes fluorescence spectroscopy and phosphorescence spectroscopy and luminescence spectroscopy respectively for fluorescence, phosphorescence and luminescence. Then what is a fluorescence in this case? So when a beam of light is incident on a certain substance, they emit visible light or radiation. This is called as a fluorescence. That is, when beam of light incident on certain substance, they emit a visible light or radiation. Simply it is called as a fluorescence. Then fluorescence state immediately after the absorption of light stop as soon as incident light is cut off. So it is the immediate process of incident light is certain substance and then it will emit the visible light and stop immediately after the incident light get cut off. So the substance that shows this type of phenomena is known as a fluorescent substance. Then next is phosphorescence. So we want to know about what is phosphorescence. So when a light radiation is incident on a certain substance, they emit a light continuously even after the incident light is cut off. So it is a different phenomena from your phosphorescence. Means there is a light emitted continuously even after there is an incident light is cut off. So we can remember the difference from the fluorescence and from phosphorescence. So this type of the delayed fluorescence is known as a phosphorescence. So substance showing the phosphorescence are known as automatically the phosphorescent substances. So it is simple phenomena we compare with the fluorescence. Then chemiluminescence. So chemiluminescence provide the electronic excitation by the energy derived from a chemical reaction. So name itself indicate that chemical is involved in this luminescence. So it becomes chemiluminescence. Such reaction may brought about in natural biological system, and for example it is called as bioluminescence. So first we'll get idea about what is fluorescence, then phosphorescence, then chemiluminescence in this way. Then important thing is related with this phenomena is the principle of fluorescence. So when a molecule absorbs electromagnetic energy, this energy usually lost as a heat as the molecule is deactivated via the collision process. So it is simple thing is that molecule absorb the electromagnetic energy and usually it loses the energy in the form of heat and it is deactivated via the collision processes occurred in this case. So some molecules lose only part of the energy via the collision. So energy get loose in the form of the collision takes place in the molecule and then the electron drops back to the ground state. So it is the way of the electromagnetic energy is absorbed by the molecule and they come into the ground state. But before coming into the ground state, there is a collision of molecules which takes place. Due to that collision, some of the energy get lost in this process and lose in this process, and due to there is different types of the phenomena occur during this fluorescence. So by emitting the photon of a low energy, that is longer wavelength than was absorbed in this case. So this phenomena is called as fluorescence, that is emitting photon of lower energy is absorbed and is called as fluorescence. And as emitted 5 to 10% of all molecules fluoresce. Then especially when excited by the energetic UV radiation. So we refer to understand this principle. So this is the figure of Jablonski diagram that gives the proper indication of the fluorescence phenomena or idea about what is the fluorescence. So this is the vibrational levels of the absorbance of particular substance and the molecule from the particular visible or visible radiation and form the fluorescence. So this is of a ground state. This is of a ground state. from S0 to S1, that is it is a state S0 to S1. So absorption of energy takes place, and there is a non-radiative transfer takes place, overcome the molecule to the ground state and forms the fluorescence in this case. So energy get absorbed, absorption takes place, and molecule get come to the ground state again. So during the coming to the ground state, molecule shows the different types of the changes in states. So this is the energy level diagram, detailed energy level diagram. From that we come to know what type of the changes is takes place when molecule come to the ground state. So energy level diagram, it's also called as a Jablonski diagram, shows the absorption process, relaxation process, and their rates. So this is S0, S1, S2, T1. There is a vibration, relaxation, internal conversion, absorption of energy, intersystem crossing, quenching, then phosphorescence, as like this. So we will come to know what they are from this slide. So what is a singlet state, excited state? So singlet means an excited state in the which all electron spin are paired. So these are electron spin are pair, singlet excited pair. So pair takes place in this case, the spinning of the molecule. Then fluorescence emission of a photon, fluorescence emission of a photon when a light return to lower energy state with the same spin as higher energy state. So photon or a molecule get returned to the return to the ground state or energy level state, lower energy state with the same spin of higher energy state. So this is of the fluorescence emission. So fluorescence emission takes place in this case. Then there is a triplet excited state. The excited state in which the unpaired electrons pair spin occur, unpaired. So it is an unpaired electron. It is the paired electron. It is an unpaired electron get spin. So spinning it is same side. It is opposite side. So phosphorescence emission. It is fluorescence emission. It is different from fluorescence emission. That is the photon when analyzed the return to the lower energy state with opposite spin as a higher energy state. So difference is that when photon come into the lower energy state, there is a in case of fluorescence there is the higher energy, same state is there but same spin is there, not opposite. But in case of the phosphorescence there is the emission takes place with the opposite spin. Here is we'll get Idavo diagram with singlet excited and triplet excited state and singlet ground state. So vibrational relaxation. So a form of the radiation less energy relaxation, radiation less relaxation, in which an light moves from higher vibrational energy to level to a lower vibration energy in the same electronic level. So it is a vibration, there is a radiation less relaxation takes place and the same electronic level is there. So this is the energy level diagram for a molecule showing the pathway for a deactivation of the excited state. So VR means what? Vibrational relaxation. VR, vibrational relaxation. Then IC means the internal conversion. So it is in between that, internal conversion. EC means external conversion. Then AC is the internal system crossing, and the lowest vibrational energy level for each electronic state is indicated by the thicker line. So this is the thicker line for the lowest vibrational energy level. So we'll come to know vibrational relaxation in this way, that is from excited state to come into the lower energy state. Then it is a conversion from the S2 state to S1 state and transition system. Then internal